Cool. So, welcome everybody to SigNoz Launch Week. Today we have with us our front-end engineering team who have been working a lot on improving the performance and the feature richness of the product. So, how are you guys feeling today? Uh, Yunus, Vikrant, Rajat.
Hey Pranay, feeling good? How are you?
Cool. I'm good. Maybe we can start with a quick intro from you guys so that our viewers knew whom we are talking to.
All right. Hey, I'm Yunus, and I have joined SigNoz around 6 months ago, and I take care of the front end side of things here.
Uh, Hi everyone. So I am Vikrant. I take care of the front end engineering things at SigNoz. It's been pretty new for me. I joined SigNoz I think almost 2 months back for now.
Hello everyone, my name is Rajat. I'm the second front-end engineer in SigNoz. Joined around 8 months back, and I mostly take care of the building features, solving bugs in SigNoz.
Got it. Cool, guys. So thanks for joining in and looking forward to what you have been working on. Uh, let's start with quick introduction of why do you think monitoring is important in front end. So we talk a lot about monitoring in our product, but generally we speak primarily more on the backend services. But I wanted to get some perspective from you guys on is monitoring important for even for front end, and if yes, why, and how do you guys think about it?
So, it- so front end monitoring or like observability will help you identify any performance issues or any errors which are not reported to backend. Like or like being logged from the backend side of things. Like let's say you have missed adding a safety check and you are trying to access a property in the UI which is not present, and that time the, the user interface will fail. And when that happens, users will not be able to use the application, and that is a very bad experience for the users, and they will start complaining about the application being not accessible. And let's say the other another examples would be like, let's say your API is taking a lot of time and you are just not showing, like you're not improving the perceived performance of the waiting experience. That is also a very bad experience. So you can then identify these things using observability and then work on top of these to improve the experience of the user.
Got it. So things for which the signal doesn't go to the backend services, I think that's what gets captured in the front end monitoring piece, right? So like I think for our product we have primarily been till now been focused more on backend services and tracing logs, etc. Most of those signals are being generated by backend services, but we have heard a lot from a community and our users that they also want to monitor front end, right? Because
Mhm.
you ultimately want to tie what is happening in the front end and with the backend. So if everything is in a single place, that makes much more sense. I think you guys have been working a lot on how we can do this in SigNoz and what could that construct look like. So
Mhm.
yeah, maybe share with our viewers like our initial thought process on that and what today you can do with SigNoz around front end monitoring, client monitoring.
Yeah. So front end monitoring can be divided into multiple aspects, right? First thing we is like an error monitoring, like or exception handling or exception monitoring. So exception monitoring comes of like whenever there's an exception that is captured and reported to your system. That is one way of monitoring for front end or observability for front end. And then comes observing the performance of your application. You can monitor your application performance by logging in the FCP, the LCP, time for first byte, the first interactive delay. So these are the metrics which are generally called as web vitals, which we can log into your system, and like you can meter them and like use a metrics reporter to report it to your system, and then observe it so that you can know that the changes with respect to your performance of a particular web page. So for every single web page, if you have this logged in or like you have got this reported, you can keep an eye, like if there's a drop in your performance of a particular page or a particular component, and then work on top of it. And with this insights, you can then see what are the most features your users are using, and how it is performing with a lot of data, and what are the steps you need to take to improve it. So because most of our like we don't have a lot of information about this related to open telemetry online, so we are trying to build learn this ourselves and like set up this so that we can then uh, write content around this and bring more awareness around this, and then make SigNoz compatible to support front-end telemetry out of the box. So
Got it.
primarily, we'll just show you a dashboard around this where we have built, we have set up our web vitals for a particular page in our actual website, like in SigNoz application itself, and then we'll walk you through like how it can help you improve the performances along the way.
Got it. So, so yeah, Vikrant, do you want to share more on that, or
Yeah, let me just get started with presenting the dashboard and then we'll talk along the way.
sure?
So this is our SigNoz application. So we have a dashboard called SigNoz Web Performance. So we plot here our LCP, the TTFB, the largest contentful paint, time to first byte, first contentful paint, and first input delay. These are averaged over the last time p range that we are considering right now. So this gives you a brief idea about how your application is performing at particular instant. Let's
Vikrant,
say,
maybe if you before you go ahead, can you explain to us like what is the difference between, for example, LCP and FCP? Just
yeah, sure.
explain what are the terms which you have used here.
Definitely. So coming to the LCP first, largest contentful paint. Like this is a core web vital that has been decided by the Google standards. Now, why specifically largest contentful paint and what it actually means is when at a particular instant of a web page load, there's the largest item in that viewport is rendered. Let's say we have 20 different images, 5 different text boxes in our web page. So let's say the first text box was the longest text box or the largest text box. So when was that exactly rendered? That is how we calculate the largest contentful paint. So earlier this was being referenced by first contentful paint, but we can think of as first contentful paint might not make sense in a lot of the cases. Let's say a loader appeared, or let's say a small heading appeared, but users are not interested in that heading or the loaders, but they're actually interested in the main content of the page. So that's where LCP comes into the picture, and it supersedes the FCP. So moving from LCP, the FCP we just
So
considered.
LCP should always be higher than the FCP. Is that
Yes,
correct to say?
yes. Yes, that is correct. This is the first will always come first, and the largest comes after the first. Might be the first one is the largest, or might be some nth element is the largest.
Got it.
So this comprises your LCP and FCP. Coming to the first input delay. Now, what happens is, let's say a performance of your web is measured in three terms: loading states, how well we handle the loading states, how good is the visual stability, and how good is the interactivity. Now, loading states is being handled by largest contentful paint, first contentful paint, and second comes is interactivity, how interactive your web page is. Let's say a web page loaded, your largest element loaded, that's well in some actions. Your main JavaScript thread might be blocked by 100 other things that are happening in your application. Might be 20 API calls are going, some tables are being rendered. So that makes your main thread unusable. So your main thread might be free from some minor instances in the middle from where you might initiate a user action. Let's say user tries to scroll down or user tries to type something into an input box. So, but if the main thread is busy, it'll take some time to respond back to the user. So now that difference of that response time back to the user is called first input delay. Ideally, by web standards, your first input delay should be less than 100 milliseconds. These are the standards set by Google. Now, last comes into the picture is we covered loading states, we covered interactivity, and now we'll look towards our visual stability. Let's say a user loads a web page. Now, once a web page is being loaded, there should not be any content layout shift for the web page. For that is measured using CLS. Like we have plotted some of the CLS graphs here. We'll come to that. So CLS, what it means is cumulative layout shift. So let's say you are rendering a web page that has 2 or 3 different buttons, and dynamically an ad comes into picture, and your checkout is replaced by cancel, or a cancel is replaced by checkout. So you can mistakenly buy an order or cancel an order which was not an intended user action. So the measure of the CLS gives you the data, like how frequently your layout shifts. So how does the browser calculates your content layout shift is how frequently the start position of your elements changing with respect to some other element coming into the picture of UI. So these are the few basic core web vitals that we leverage as of now, and these are being used to determine what kind of a website performance that we are looking at. So we can use SigNoz to render such data on our dashboards. So how are we rendering this data? A brief about it is we are leveraging the async meter from the open telemetry specification, and that is being used to render the data on the screen. We are capturing data on different kinds of pages. We are averaging that data out, and we are uh, plotting that data on the dashboard. So these are some
How are you
average values.
getting that data? How are you getting the async gauge like data in that meter? Are you using any custom
Yeah, so
metrics or
right. So we use a Web Vitals library. The Web Vital library that exposes us all these core Web Vitals data that we require. And once we get that data, we have our own open telemetry instrumentation setup. We create a custom meter. We expose it to our application via meter provider. And once our meter provider gets that data, we ingest that data into the SigNoz, and we visualize that data here. So this comes under your uh, averaging out data, and this comes under your chart. So now let's say this is our main chart. So we tried different strategies to get out different data. Like we tried our application with slow 3Gs, we tried our application with 2Gs, fast 3Gs, and without no throttling, and we ended up with different results of our data. Now you can we all these core web vitals have different web standards specified by Google. Let's say under 2 milliseconds of LCP is good performance, under 4 seconds of it is that it might need some improvement, and at above 6 seconds it's like it's very critical, you need to fix it right away. So we can plot those thresholds in our SigNoz application. Like let's say we'll go to the edit of the dashboard. We have the last 1 hour of data here present. You can define your thresholds here. Let's say 2 milliseconds or 2 seconds is good for us. 5 seconds, we might look into it. It needs some improvement. Critical is above 10 seconds. These are all these are not standard values. These are just for depicting purposes. You get all your data plotted here. Like, okay, your graph is going above, needs improvement here. That means you might go and look into it. Sometimes you get a good performance out of it. So depending on these data, you can create your thresholds, and you can decide your y-axis unit. Like let's say my unit is milliseconds or seconds, and you can define different matrices here. Now after this, let's say above a certain point of time, let's say it crosses critical threshold, you want to set up an alert for the same. You want to be notified. You might not want to come back to this page again and check is it above critical or below critical. So you can simply go and create an alert for the same from here itself. You can leverage the same query. You can define your y-axis units here, or milliseconds or nanoseconds. Let's say we define it as milliseconds. We can define when a particular rule it exceeds above the threshold, maybe once, all the times, on an average or in total. If it at least once exceeds your threshold in the last 24 hours or in the last 5 minutes, we wanna, let's say it increases 4 seconds. 4 seconds. You wanna be alerted about the same. You can select the severity of the alert. You can select your notification channels where you wanna get notified for the same, and you'll be notified in your Slack channel for the subsequent alert threshold crosses. You can see your alerts like this, and when the alert is being firing, you can see the firing alerts as well.
Got it.
So
So the dashboard which you have shown, the critical, the red line, yellow line, and the green line, these are just a visual indicator as of now.
yes,
They are
like
not actually firing any alerts. So these are just visual indicator to show you that okay, you need to maybe look into it, and then if you want, you can set up alerts, which is the next step. If you
yes,
want
right.
to get alerted based on that. Got it.
Okay, for a better example, let's consider somebody's from the growth team or somebody who's actively monitoring our website performance, right? Because website is one, consider Facebook, and that's uh, your landing page where users are like continuously viewing data and everything. There's threads and everything which is shown up, and the performance of this falls, and because of this, users are not able to use the application properly, right? So these alerts with these metrics, what you can do is like set up alerts, and there would be somebody actively monitoring these things, or be alerted when there's a drop in performance, and people can decide whether to roll back a previous release if that has happened due to a previous release. And these metrics help you with respect to your application performance. And like with SigNoz, you can set up an observability alert around it, and then do your uh, observability around it. And this is very specific to performance, right? Whereas apart from this, also there's a lot more metrics specific to front end which you can observe, right? You can use a lot of web provided APIs to measure your performance. You can also use Lighthouse score, right? Like every single um, release when we do for our main website, I want my Lighthouse score to be optimal, and it need not drop. As we don't control a lot of elements on the UI with respect to our main websites sometimes, because there are ads coming in, probably there's uh, new set of components which we have built which we have not tested for a particular performance level. We can set alerts around this and get notified and make our decisions whether to continue with that or like roll back or fix it as soon as possible. So there are a number of metrics which you can send from your application specific to front end that help you observe your web application performance.
So can, for example, somebody monitor their Lighthouse scores using SigNoz?
Yes, they can do that. So if there's a library to generate a Lighthouse score for a specific page, and you can use the same methodology to report that and keep a monitor around it. You can create a panel. You can create a panel around it and set up thresholds, set up alerts, and if there's a drop, we can, with sending additional attributes along the way, we can know that what release caused this problem, and then make sure that if you want to go back to the previous release or fix it as soon as possible.
Got it. So this could be very interesting. Like I remember in earlier days, we used to monitor Lighthouse score for SigNoz website quite proactively, and this would have been very useful for us if we can get alerted if the Lighthouse score dropped below a certain level.
Yeah.
Cool, Vikrant, you can, if you have more things to share, you can cut.
Yeah, sure. So another thing that I like pretty much in the application right now is, let's say I'm seeing a graph, and at some point of time I see a critical thing happening, or like this particular area, some spike happened. So I want to know more about it. In a general overview, I'm not getting much detailed picture about what happened particularly here. So we support this graph zoom in here. So you can zoom in into that particular section where you want to visualize what happened. We can look into specific details around, okay, around 11:40 to 11:45 some spike happened. This might be the time you release something new. This might be the time a new tenant got added. This might be the time some X event might have happened that have caused this. This helps you limit where, when exactly what happened, and you can look for further details about what were the metrics at this particular point of time. This feature is it helps a lot in debugging skills
I
as
think
well.
what would have been even more interesting is if somebody can click that spike which you have seen and go on to say exceptions or the infra where it is hosted. So that would have been like really useful, I think. Like for
Right.
example, here if you click on this one, I think we have something similar for application metrics where you can click this and go to traces.
Yeah.
Right.
If you have something similar here, I think that would help users debug to the next level. That okay, why is this happening? Like we know now something is wrong, but now users have to manually take this time and go to the next step to figure out like what's wrong. If we can show that to them here only, that would have been used. Maybe this is something food for thought for you guys to uh, work on next.
Right.
Yeah.
Also, we can select a custom label here as per the attributes and add some details here. But definitely, like navigating to that particular place where something happened would be really helpful. Moving next, performance we measured for a UI application. What next thing is that UI developers or any business needs. If at any point of time some error happened, you want to instantly know that something happened, something went wrong, some 4 applications are down, some 5 customers are facing some issues. So how do we go around that? So we have our own dashboard for SigNoz UI error tracking. Let's say for the last 6 hours, what errors happened? I just want to know. So you can figure out, like, let's say 26 errors in the UI happened in the last 6 hours. So, and you can put specifically, we leverage our list view here for traces to plot this particular data. Now I know a particular trace, this particular trace generated some error. You can click on it and you can go to the detailed trace. You can check, okay, this is the error boundary. Something was caught by the error boundary in our web application. The error message was something went wrong, and it was occurring in logs and logs explorer page. So you know, okay, something in the logs page is not working correctly. And if you want to know the detailed stack trace as well, you get the detailed stack trace here as well. Now, if you record these exceptions, like if you record exceptions in the span, they'll be pretty much visible here as well. You can see all the exceptions that have been logged. What was the specific error at that time? Okay, though this is the stack trace that happened during that time. That means something in the list mount happened. Something was not flushed properly. What was the span ID corresponding to this stack trace? What was the trace ID where this error was captured? And on the exceptions page itself, we can see, okay, this error has occurred 6 number of times. So that it might be something serious. It might be something that has happened 2 times, might be intermittent. Something that has happened more than 5 times, maybe. You can define your own custom metrics, and you can trigger alerts on the basis of if some error in the last 10 days or in the last 10 hours has occurred more than 20 times. That means it's very critical for the business to look into, and they'll generate alerts for the same. And you can set up the alerts based on your exceptions, based on your metrics, based on your traces.
So are this
So
error tracking dashboard which you built, was that primarily powered through traces? Can you show the
Yes,
queries there?
this is powered to the and traces list view.
Got it. So you have an error message coming and you're just filtering and showing that, okay, what that
yeah.
message is.
Yes.
So to add on to that, Vikram, can you go to exception?
Yep.
Yeah. And open a particular exception. So as we can see the complete error trace, if you see this is not very readable. The reason it is not very readable is because we don't have the source map mapped along with this. So we need to map our source maps so that we are able to point to the exact line in the code. And once we are able to do that, we'll be able to see the complete trace pointing to the line which caused this error. So we are working towards it. It's not done yet, as it's one of our aspirations to build complete front-end monitoring out of SigNoz itself. So we'll be moving towards that in our next discussion. So with that, we'll be able to handle complete error monitoring from end to end, like how other products also do.
Got it. Cool. So this looks quite interesting. I think people can now share monitor their web vitals and set alerts on top of that, and then also start monitoring what errors happened, basically powered through the traces, and see them in a single dashboard.
Yeah.
And understand like what's going wrong and what areas they need to focus their attention on. Do you have anything else to share, Vikrant? Or
Back
this
to you,
is
Brennan.
okay. Cool. Thanks. Cool. So thanks for sharing that demo, Vikrant. Looked quite good. I think one question which I had, which is like slightly different, was because SigNoz is a very unique type of product in the sense that it handles lots of data, and even from a front end perspective, we spend a lot of time in performance and optimizing performance around that. So what are the what have you seen as the unique challenges which you see as front end developers working on a product like SigNoz? Give us some sense on that. Like, how is it different from working on other products? What is easy? What is hard?
So, to as you said, right, we are very data intensive. When a particular user wants to go through a trace, and then there are n number of spans being rendered in the UI, it is pretty like the more the number of nodes in the UI, it is the browser performance takes a hit. And as and when we have a lot, because a single trace can have thousands of spans inside it. So rendering them performantly is a very difficult task. So that is one thing which is not very. I have not done this before in my career because I've worked with different companies. They have a different performance issues which we take care of. And when it comes to logs, there can be tens of thousands of logs during a particular time duration. Rendering those is, like as I said, right, the fundamental problem with rendering a lot of nodes is your your browser will take a hit because it doesn't have a huge amount of resource to compute everything and render so many nodes in one go. So that's where your slowness comes into picture. And take an example of graphs, right? So for a time series can have thousands of data points. Rendering one single time series takes a hit because it most of the libraries use canvas and they are render blocking and they take time to paint on the UI. So in our case, it's not just one time series. It is a single panel can have n number of time series. All can have, like say, a single time series have 10,000 data points. It is basically multiplied by that number of times for a single panel. So if there are 5 time series, it is 5,000, 5 into 10,000 data points to be rendered on a single panel. And we just don't stop at that. We then plot tens of panels in a single dashboard. So that's why previously we have had complaints from customers saying that, okay, your dashboard is not performant. It becomes non-usable at some point of time for a large data time range. Let's say somebody is plotting or like trying to see a data for one day. That is a comparatively smaller data point. But let's say somebody chose 6 days, 7 days, or like a month. It is like it will have lakhs of data points to be rendered on UI by the chart. So that's where the performance will take a hit. So there are two types of performance improvements we can try in this case. So one is a perceived performance. Another is an actual decision making on how your chart is being rendered and presented on the UI. So we were previously using Chart.js for rendering our graphs in our UI, but with the huge data set, it would take a hit and the rendering would be blocked. So your UI used to get blocked. So now, then we were evaluating on the libraries which are already available in the market. We considered D3, Charts, and other Chart.js, and then now again we considered uplot, which is another lightweight library, and we saw that the uplot library had better performance for even large data sets, especially dealing with time series. And our representation when it comes to large data sets was based on time series. Our visualizations are mostly time series, which we support as of now. So we evaluated uplot, and we were able to see there's huge data performance gains that we could achieve using uplot. But the problem with uplot is that it doesn't have a great documentation as such. They have just their library and examples. So you go figure out how it is implemented and then try and set it to as per your design languages and then update it accordingly. So that is like a time consuming process. And we are very fast-paced development team, and we cannot afford to do that. But we had to do it because performance, if you fix the core problem of performance at one first, and then you can improve on perceived performance. Like when I say perceived performance, you can choose to show around only X amount of data points in your browser, because browser has limitations. You, the browser is again dependent on your hardware again. The performance of your browser is also dependent on your hardware. So there's a domino effect that if you have a lower hardware design, like it is not very performant, your browser will also not perform accordingly. And it depends on n number of tabs open in your system, because browser will take more processing time and the CPU, and that way you will see the lags. So we need to make decisions around this such that your perceived performance also improves. So we choose the number of data points we want to plot in the graph. We want to limit it. We want to show, okay, this is how you can do. Like this is the maximum number of data points you are plotting, and this ranges between X and Y. And that way we are able to do it. Now we then move towards loading only the uh, instances which are visible in the screen, and like unmounting everything which is not on the screen. That way it is taking less compute. Your browser is taking a lesser hit to compute what to render, and that way you are able to improve the performance around it. Now we are more considering introducing grouping for panels, right? In a dashboard you can have n number of types of panels. Once you group them together and it is like let's say collapsed or anything, only the skeletons will show up. It will not be the actual graph until you interact with the graph. The moment you try and interact with the graph, the actual graph is plotted, and that way you will be able to interact with the graph, see all the details around the graph, and you will create less load on the browser, right?
Got
So
got
it's an interesting problem to solve. Yeah. So that
got
way
it. So it seems like you guys have done
we
a lot
have
of
to deal
work
with a
there,
lot of data,
and yeah, like I think still you there are like a lot of ideas you still need to explore to make it like one of the most performant already product. We have also worked a lot on like releasing new feature and like standardizing what libraries we use underneath, and like the overall product design should look in a very consistent framework. I think Rajat has worked a lot on those areas. Rajat, do you want to talk about that? What work you have done there? What impact it had on the product as such? Would love to, I think, hear more from your work there.
Yeah, sure, Pranay. So so when the front end parts comes into picture, so what we have done is like we have introduced design tokens. Design tokens is like a building block for the design system, which represents colors, which represents sizings and typography. Why we have introduced design token was like it helps like maintaining the consistency and making the and making the front end code more stable. When I say like maintaining consistency and making the code stable, so as you can see in this whole SigNoz repository in the front end code, we have like hundreds of buttons. What we previously used to do is like hundreds of buttons will be having hundreds of css written, separate css written, and when the designer was like, okay, we need to change the color of the button to what we have in the SigNoz logo. Like what I used to do personally was like go to every file where the button is present and change the color, change the sizing, change the typography, and
So that
that
would
was like,
become very cumbersome,
yes,
right? That would
yes,
take a lot of time, and also you can miss some buttons, and that would introduce
right.
inconsistency.
Yes, and maybe like by mistake I can change the color. It will look slightly different. So it was not stable, right? So like we have introduced the design tokens. So like it is a single source of truth from where all the tokens like colors, typography, sizings will come, and we will be propagating it to the front end core library. So that's why like so whenever the designer will say like, okay, I need to change the color of all the input fields, maybe the select field, there is one single source of truth where we can change the sizing and the colors, and it will propagate to whole SigNoz library. So the
Got
next
it.
step,
Got
like, what we were thinking of doing is like we will be building the component library. So now what we are doing in front end code is like manually handling the theme of every component. Now when the component library will come into picture, it will be having the basic components like buttons, like input field, like select, table, everything, and we will be consuming the component library, the components from the component library into the SigNoz. It will help in automatically theming, automatically using the design tokens, and yeah, whatnot. So
Got
that's the plan. Yeah.
Got it. So I think this would help you make the experience for end users much more consistent, and even for you as a team to ship features much faster and
Yes, the
reliably.
development will be faster. Yeah, for sure.
Got it. Cool. So I think we have heard a lot about one part on what metrics users can now monitor in SigNoz and what are the ways you can monitor your front end via SigNoz. We saw how you can create alerts on that and also monitor your errors and exceptions. I think Ines talked about a bit on what are the unique challenges and then how we are designing the front end to be much more scalable using design token and component libraries. What's next in plan? Like, what are the things which are building next? Give us some glimpses of that, and where is this going? What are we building from front end engineering perspective in SigNoz?
So when it comes to like the front end specific features, right? Like we want to work more on front end specific features, which help improve the experience of using our product. So that way, currently we have already started working on the keyboard shortcuts framework, which probably say Vikrant can talk about more on the keyboard shortcuts framework which we have, and then front-end specific features, when we talk about that, it is like working towards the, as Rajat mentioned, about building a component library out of it. Building, and then one thing which I want to build is creating a framework which can help our content team bring in copies inside our system without accessing the repo. Like there would be copies which probably you have told me to update most of the time, like, okay, go ahead and update the text to be so and so, and there would be, the whole copy needs to be in line with what the marketing team or the product team wants to keep it as, right? So this is like too dependent. You have to wait for me to go and update it, and then the release happens, and that's where the delays comes into picture. Like it takes, let's say if you are not blocked by other things, it will take a couple of days to get that simple text change into the picture. Whereas we can build systems such that you just go and update in a separate repo which is maintaining our copies, and that reflects in our application without having us to release an application. So that is
Got it.
something which we want to work on. And the most important, or like the most interesting thing which I want to build at SigNoz is building our own front end telemetry setup. Whereas, like as you're able to set up exceptions, you're able to monitor web vitals. We want to build a suite of, let's say, APIs, or like, let's say, components with which you can easily integrate front-end observability into your systems. Let's say you have a error boundary component, which SigNoz provides you an error boundary component. It logs all your traces without you doing a lot of anything else apart from that. You just have to wrap your existing components with an error boundary component. So that way, all your traces with error stack will be reported to us, and you can monitor it in SigNoz application. Providing out of the box dashboards for front end telemetry. So you say, I want to monitor web vitals for my X page. So you can just say, you can provide us the URL, your dashboards along with the metrics we showed, right? Time for first byte, time, first interactive delay, FTP, LCP, all those things are generated by default for you without you having to do any more setup around it. And improve on exception reporting. Like as I said, right? If you have the source maps baked in, or like access to the source map, you'll be able to see you can see what button click triggered this problem, what function call triggered this problem. You will have a complete stack trace around it. And then real user monitoring, which we don't support as of now. OTel is lacking behind around with respect to real user monitoring. That is something which you want to build out of the box if you use SigNoz. We want to provide that feature out of the box.
Right. So lots of interesting and new features to to be working on. Cool. So thanks for sharing all this, guys. I think looking forward to what you will be building and hope what we have shipped till now is loved and enjoyed by our users and community. See you. Bye bye.